Soil management. Welcome back. In this episode, we're covering soil management, which accounts for about 7% of the certified arborist exam. Even though the percentage is smaller than some other domains, soil management shows up everywhere on the test. Planting, decline, water stress, construction damage, and nutrition all come back to soil. By the end of this episode, you'll understand how soil supports tree growth, how water and nutrients move through soil, and how arborists assess and improve soil conditions in real-world settings. Let's start with the big picture. Soil is not just dirt. It's a living system with physical, chemical, and biological components, and the exam expects you to understand how those components interact. Soil formation and horizons. Soils form over time through the weathering of parent material and the accumulation of organic matter. This creates soil horizons or layers. You don't need to memorize every horizon layer, but you do need to understand that. Surface layers typically have more organic matter. Deeper layers often have less oxygen and biological activity. This ties directly to root distribution, which is a recurring exam concept. Physical characteristics of soil. Physical properties include texture, structure, and bulk density. Texture refers to the proportion of sand, silt, and clay. Structure describes how soil particles aggregate. Bulk density reflects compaction. On the exam, compaction is a major red flag. High bulk density means reduced pore space, less oxygen, restricted root growth, and poor water infiltration. If you see decline symptoms paired with foot traffic, construction, or equipment use, soil compaction is likely the underlying issue. Chemical characteristics of soil. Chemistry focuses on things like pH, buffering capacity, and cation exchange capacity, often shortened to CEC. CEC describes soil's ability to hold and exchange nutrients. Clay soils and soils high in organic matter usually have higher CEC than sandy soils. Exam tip. If a question involves nutrient availability or fertilizer effectiveness, CEC and pH are often the hidden drivers. Biological components of soil. This is one of the most important and often overlooked areas. Soil biology includes mycorrhizal fungi, microorganisms, macroinvertebrates, organic matter. Healthy soil support beneficial relationships, especially mycorrhizal associations, which improve water and nutrient uptake. On the exam, living soil equals resilient trees. Sterile, compacted, or disturbed soils equal stress. Urban soils. Urban soils are rarely natural. They're often compacted, contaminated, layered with fill material, low in organic matter. Many exam questions describe poor tree performance in urban environments. The correct answer often involves soil remediation, not pruning or fertilization alone. Soil sampling and interpretation. Arborists must know how and when to sample soil and how to interpret soil test results. The exam focuses on proper sampling methods, understanding what test results actually mean, avoiding unnecessary treatments. A common exam mistake is jumping straight to fertilization without evidence. The best answer usually involves testing first. Water and soil interaction. Now let's talk about water, which is tightly linked to soil structure. Water movement depends on soil texture and structure, drainage, pore space availability. Poor drainage can lead to oxygen deprivation, while sandy soils may drain too quickly and cause drought stress. You may also see questions about water budgets, irrigation timing, or supplemental watering. The exam wants you to think in terms of matching water management to soil conditions, not applying blanket solutions. Soil volume, nutrition, and amendments. Trees need adequate soil volume and structure to support long-term growth. In urban settings, this often requires engineered solutions like structural soils, soil cells, root paths and trenches. Nutrition topics include macro and micronutrients, fertilizer types, and release rates. Application timing and methods. Exam emphasis here is on needs-based fertilization applied according to industry standards, not routine or cosmetic feeding. Mitigation and improvement strategies. The exam expects you to recognize when soil needs improvement and what strategies are appropriate. Common strategies include mulching, aeration, vertical mulching, pH remediation, soil replacement or amendment. If a question asks for the best management option, it's usually the one that improves soil conditions long term, not the fastest short-term fix. Exam focus callouts. Watch for these patterns. Decline symptoms tied to compaction or drainage. Nutrient issues linked to pH or CEC. Urban tree stress explained by soil limitations. Fertilization questions testing restraint and evidence-based decisions. If the soil is poor, the tree will struggle no matter what else you do. Rapid review summary. Let's lock it in. Soil has physical, chemical, and biological components. Roots need oxygen, space, and proper structure. Compaction and poor drainage are major stressors. Urban soils are often degraded and require mitigation. Soil testing guides responsible nutrition decisions. Long-term soil improvement beats short-term fixes. That's soil management. If you understand soil, you understand why trees succeed or fail. And that's exactly what the exam is testing. Next up, we'll move into installation and establishment, where soil knowledge meets planting success. Thanks for listening to the Arborist podcast. Let's keep building your arborist knowledge one domain at a time.